about that at the end of that. Okay, 1 minute. Okay, so to give a quick background about what we did is from IIT Madras, we formed a team called FinLibre. Today it is called as Data Libre. I'll let you know why we call it as Data Libre these days. So our most the important thing that we wanted to do in data analytics is we wanted to create an ecosystem. Okay, you could say an ecosystem, or a knowledge base, or you could say a kind of tool set which will help many of the companies in the industries to use data analytics platform without actually paying money. So we went completely open source in order to make this. So just to give you what all things we did. Okay, so see, what happened was, what are the, see, as an industry, as a financial industry, or any industry for that matter, what we wanted was, we wanted to create a kind of tool set which will basically help the end user to create a dashboard on his own. Right? Suppose if you want, suppose now that you are given some set of data and you want to do some analytics on top of it, maybe you want to get some insights on top of it. Now, to do this on a regular basis, you would actually need a techie. You would need one guy who can write SQL. You will need one guy who can load the data into the system, right? And you might need one guy to create a chart for you. So basically, you will need a techie. But if you look at banks or insurance, especially with what we call it as the BFSI sector, banking, finance, securities, and insurance. Banking, banking and finance, right? Securities is nothing but your stock market, okay? And insurance. So this BFSI sector, there is a huge amount of scope for data analytics. You can actually find lot of insights into data analytics, how people are buying, how people are spending, how much they are spending, where they are spending, on what they are spending. Like that, there are so many things that can be brought into. There are so many insights which help the businesses to grow. Now, the problem here was, banks had the data, the insurance companies had the data, but the problem was, how do I create a visualization, or how do I create a dashboard out of it? Now I don't know to code, right? Or I'm not, okay, I can to some extent code, or I can to some extent write some small logic or something like that, but I'm not a techie, right? I understand how to browse a website and all these things, but I am not a techie. So this is one of the interesting and important challenges that the industries face. Many of these financial sectors and other data rich organizations, when I say data rich organizations, is any company which has come up after 2000, right? Facebook, Google, all these companies, all these data rich companies, they are divided into two. One is technology companies and the other one is non-technical companies. Like for example, a bank. Okay, a bank's core job is not technology. Insurance companies' core job is not technology. They say somebody who is providing the technology for them, but their core job is not technology. There is a manager, there is a there's an officer. Everybody is there. They all have access to data, but what they are not able to do, they are not able to bring out insights from that. They are not able to predict the data using they're not able to do it. Suppose if I want, okay, suppose if I give the past 5 years of data to Ishan, right? He will develop a neural network and say what will be the sales for the next 1 year. But then for that I need Ishan. Okay, but what I want, I can't have so many Ishans. There can be one Ishan or maybe 10 Ishans. But every other organization, I cannot have an Ishan. But what I can do is, I can create a technology, right? Sorry, Ishan, I'm not trying to replace you, but I'm trying to replicate Ishan in so many areas, so that whatever work can be done without a human intervention, without writing a code, without technology, if I can do, That's something great. That's the major aim with which we started the Finlibre consortium. Now, in a financial analytics, suppose if you're looking at a financial analytics, what we are actually trying to do, I have data, I would like to create an ad hoc analysis. What do you mean by ad hoc analysis? Suppose somebody says, give me a report which compares the loans before and after Corona. I just ask a simple question, right? This report is not predefined. I ask a question to my team saying, please give me a report of what is the sales before and after Corona. It's an ad hoc report. So this is on demand. Anytime I can come and ask. I can come and for 5 p.m. to 6 p.m. on all Thursdays. That's it. It's just a ad hoc question, right? So there is data available. There are there'll be some predefined reports like say monthly bills, hourly bills. All these normal reports will be there. Other than that, I might have some ad hoc questions, right? I might want to see the data for next few hours or something like that, or I want to find the what is the sales pattern over the last 4 years only on Sundays. I might ask, right? So there could be so many such things. For this, the data is available in the database. I would need one SQL guy who will write the query and give me a report. Again, that report that if he gives it as a report, then it won't make sense. I would need it as a nice visualization, which will make it much more easier for me to understand, grasp it, digest it, and all these things. That is one important aspect of the financial analytics. Second one is forecasting. I want to know what will happen in the future so that I can pre-plan. I can plan accordingly. Okay. Suppose if I know that in the next few months I won't be able to sell so many products. I will not even produce them. Right. So that's how I shape the strategy for my business. Okay. Then how is my company's finance performing? If all these things I would have. And then analytics also provide some tools for gaining deep knowledge into key trends. Okay. How is my sales going? How is my revenue going? How are my employees performing? Right. We call them as KPIs, key performance indicators. So I can create dashboards for these key performance indicators, which will do all these things. So now, the point is that these financial companies have very huge amount of data, and from this data, what we want to gain. Okay, that's the important thing. So, if you look at the, the basic disruption happened in the banking industry because of a digital thing. Okay, now you have mobile banking, you have phone banking, you have ATM, you have phone pay, you have so many options are available. So the data is coming from multiple sources. You can't imagine the way in which the data comes from. The data comes from mobile phone. Suppose if you take a single bank, okay, just imagine the number of channels they have. They have a core banking system where the actual transactions happen. They have a loan processing system. They have a customer relationship management system. They have a HR management system. They have a mobile banking. They have UPI. They have forex. They have commodity. They have foreign exchange. They have a Swift, NEFT. There's so many channels in which the data comes in. There are a lot of verticals these data is coming from because of because you can now perform financial transactions through various channels. One way it is advantageous to normal citizens. At the same time, it is also opening, multiple doors for hackers. Suppose if I say I am having so many doors in my house, so that because if something happens, I can escape from any door. That will also give rise to the thieves to come from any of these doors, right? So there are the multiple problems also coming with that. So the important challenge here for many of these banking and financial institutions was how I can manage such a large data. Okay, for that we have the big data thing. I'm not going to talk about big data, but then yes, that is one area. Then I want to make some conclusions out of this data. So I have data, but I need to have some conclusions. Right? Unless until I have some conclusions, the data is not going to help me do anything. I might want to do some forecasting with my data. I might want to understand my data to see what is happening so that I can take some decisions. Okay. I might want to forecast the future. I might want to take some decisions. Like that, I have multiple things that I can do with that. So in the last few, basically to look at the needs for any organization. I think I have explained it in my previous slide itself. So previously, so if you look at any banking or any financial or any of these sectors, one of the important things is that okay, I have data readily available, but the data is in multiple places. Loan banking data is there in a different database. CRM is there in a different database. Core banking runs on a different database. The UPI runs on a different database. The SEBI runs on a different database. If you go inside a bank, somebody is working in a bank, you will have at least data coming from 10 different databases. Now, the job of the data analyst is to see if there is any connection. Because of UPI, have the banking transactions reduced? Okay, if it is reduced, then I have to prove it. Okay, because of banking mobile transactions, are there many security lapses? Because of introducing more number of ATMs, has my business grown? Like that, there are so many conclusions that we can make to bring out the problems the conclusions from the data. So here the need for data analytics, one is how do I create a data pipeline so that, see, I'm going to be leaving you with lot of questions, not with answers. I want you to, the young brains, to think about what are all the different ways these problems can be solved. We are solving it day in and day out, but I'm also expecting the next generation or people from the academia come out with various ways to solve it. Now, the data analyst job is to create a data pipeline from where I can pull in the data from multiple sources, create a common data model from where I can do analytics. Now, when I'm getting the data from multiple sources, the problem is there could be data coming with huge velocity, huge variety, huge volume, huge veracity, huge variations. Then that's basically big data. So if there is huge amount of data community, how do I manage this data? Then I would need one ecosystem called a big data, or like Hadoop ecosystem, or some other ecosystem which we will be able to use it and create a lot of insights into the data. And one more thing is that the top management wants to always have a visibility into what is happening in my organization. And only one way to solve this problem is to have proper dashboards. The manager wants to see just for the head of a bank wants to see only few things. How are the number of transactions going? Are they going high? Are they going down? What is the, how is the NPA going? NPA stands for non-performing assets. When a bank has a lot of business, there will be some businesses which don't perform, which is loss. The NPA we call it as, whether the NPA is going down or whether the NPA is going up, whether the credit defaults are going high or going down. So he is interested in some main business. A branch manager can have some metrics. He might want to see how many new accounts are opened in that branch, how many are closed, how many are defaulted. So everybody has some numbers to chase for. What the data analytics people have to do is that create curated dashboards for each of these teams, so that two things. One is they should not further require a technical assistance to further do it. They should be able to do it. Or I should not ask a branch manager to write an SQL query. I should not ask an MD to write the Java code to create a dashboard. So I need to have a system where they can simply work. And one of the other important or filming. Is anybody asking me a question, or okay? So one of the important aspect here is to create a system where people will be able to create these data analytics on their own, and I'll also show you how we try to solve it using our data library platform in some time now. Okay, so what are the usual things that we do? Okay, in a banking sector, what are the important things that we do? One is we create the big data applications which are um, very highly uh, blazing fast data analytics, which can show the end user easily digestible ad hoc visualization and self-service dashboard. When I say ad hoc visualizations, whatever chart I want to make, I should be able to make it within a minute, and I should be able to do it by myself. Okay? And this should happen with great speed and great end user experience. The end user should feel that he is not being bothered. He should be able to do it like a magic. Second, some of the other aspect is time series forecasting, especially predicting the sales or estimating the trends. Then we use a lot of machine learning for doing regression. Regression basically to predict the expenses, revenues, right? Especially maybe I want to know how much money amount will be withdrawn from an ATM machine, okay? So that I can load the correct amount of cash, right? And especially classification problems where I want to find out if this guy will default the loan or not. If he's going to default the loan, I'm not going to give him, right? Then we call it as customer churn. Customer churn is basically I have a new product. Can I sell it to him? Will he buy? If I know that he won't buy, I won't even advertise to him. I won't even take the pain of selling it to him. We use a lot of clustering to group the customers so that we can send targeted ads to them, right? Or targeted bonuses, targeted offers, gifts, whatever. Okay. Then we use deep learning mainly in the areas of fraud risk management. We want to eliminate a lot of frauds happening in the bank. Then we also want to understand the market sentiment. So there's a lot of tweets coming on the Twitter, Facebook. We collect them from various social media, try to analyze the market sentiment to see how people are, towards spending. Right? Will people spend this Diwali or not? Because there has been so much of chaos in the world. Will people spend this Diwali or not? We wanted to understand these markets, right? So these are all the various applications that are available in terms of the various applications. Let us just go and look at some of the applications that we try to solve, right? Especially we use the inferential statistics in banking. You all know what is inferential statistics. Is basically we are trying to prove a theory. Okay? Suppose there is a theory that exists and I want to prove it. In mathematical terms, we call it as a hypothesis testing. For example, the bank runs a campaign, okay? And I want to prove that the campaign is successful or not. Right? This can be done only by an inferential statistic. You can argue that you can do it in different ways. Yes, that is possible, but in a more traditional and a more formal way, this is done by using inferential statistics. Example, somebody says this particular fund gives on an average 8%, 8% per annum. It's a statement. Now, in this case, I might have to use a Z test or some other test, okay, to prove that whether this is right or not. Or another example is the fund performance or the 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 branches, okay, across two state capitals are same. That is the hypothesis. Okay, the hypothesis H naught. Okay, many of you would have gone through a data analytics course or something like that. So there is a hypothesis. So there is a hypothesis which says that the fund perform the uh, branch performances in city A is same as that of city B. I have to prove that statistically. I cannot just go with averages. I might have to do a proper test of it. So inferential statistics play a great role in arriving at conclusions that we want to prove. For example, one of the hypotheses that the ATM is next to a branch is not reducing the burden on cashier. So previously, the cashier used to attend uh, 200 people in a day. Then what I did is I placed an ATM next to the branch. By placing the ATM next to the branch, has the cashier's burden reduced? Have we reduced from 2 cashiers to 1 cashier? I cannot just like that say. I need to prove that by numbers, by math, and that is where inferential statistics comes into picture. So many of you who would have studied in your books or something like that think that okay, inferential statistics is not beyond books. No, we use it day in and day out in the industry to prove lot of conclusions whether they happen or not. Okay. For example, one of the interesting things that we found was people who fill the loan application forms with proper capitalizations are less likely to default. Suppose you go to a loan, you go to a you know the branch for getting a loan. They give you a form, online form or offline form. But if you fill the form by using proper punctuations, your name should start with a capital P, put a full stop, comma in the address. So if you use proper punctuations and capitalizations, it means you are a person who will follow the rules and you will not default the loan. This is one of the biggest study that was done using a huge data from various banks to prove this. Again, this was an inference. This is a classic example of an inferential study. Okay, so you can think of several things like that. So again, it's a tip for you. Suppose if you go to a branch and you want a loan, please use proper punctuations in your form. You are more likely to get a loan. Okay, take it from me. And next one is our NPAs, our non-performing assets are as per the market standards. So market standard will be one, and the your bank thing is one. And I'm claiming that our NPA percentage and the market standards are same. Can someone tell me under what test this will come? Market is the population, your branch is the sample. People who have studied data analytics might know about samples and population. Your entire market is the population, your branch is the sample. So your sample has one average, your population has one average. You want to ensure that your sample's average is same as that of the population average. What is the kind of test you will do? I leave it to you. It is one of the Z tests. You can think over and tell me what kind of Z test is. Maybe Santosh can add this as a question to the final exam. The last exam that we had, you can add this as a question. Okay. So then comes the data analytics part. Okay. Now in the data analytics, this is one of the key functions for any data analytics system. I have data and I want to create a visualization. I want to know some trends about my data. The important thing here is the guy who is using this should not, need not know technology, need not understand technology at all. All he wants is, I want to know what is the trend of the ATM withdrawals over the last few years. That's it. Plain English is asking. He has to see the answer. This is where we brought in the capabilities of data library. I'm going to show you the demo of our a small snippet of our product where we will see. Okay, so this is our tool. Okay, now I have my data here. Okay, I have my data. We will just go ahead and see the data there. So I have bank data. And I have an ATM data. There is a data that is collected from different ATMs. Okay, so there is a ID, there is an ATM, there's a transaction date, number of withdrawals, number of CUB card withdrawals, number of other card withdrawals. This is all anonymized data, not original data. Total amount withdrawn, amount withdrawn using CUB card, amount withdrawn using other card, on the what was the weekday, whether there was any festival, whether it was a working day, holiday, what is the holiday sequence. That is WHH means weekday holiday. Like this, we have lots of data. Now, using this data, data is there. Bank has this data. Now, I want to create a dashboard so that people can understand. Now, in our data library platform, we have created two things. The main aim is anybody who knows how to use Chrome should be able to do analytics. As simple as that, right? And that is what we try to achieve here. Now, for example, I have the data. See here, without even so, if I can ask you, with this data, what are all the charts you will do? You will find out which ATM your ATM money is getting withdrawn. All these, there are a lot of charts you can draw. How long do you think it will take to draw these charts? Maybe uh, uh, 15-20 charts explaining different numbers. How long you will take? And you should also know SQL. How long do you think? Just make a rough guess. I think everybody is hungry. Everybody is even. Are you all there, or you all muted your mic and gone for lunch? I'm not really sure. Okay, fine. Okay, in this case, if I have to draw these charts, okay, so we have kept a magic button. Okay? So when you put this X-ray, it will automatically draw all the required charts. So it says that total ATM, right? These many transactions have happened. Okay, now you can see that amount withdrawn using CUB card, between this much amount and this much, these many cards were used. Again, number of withdrawals per ATM. Okay, AK Nagar ATM, this many. So, and which day most amount was withdrawn? Uh, Amount was withdrawn during WWW. If mostly on a weekdays, people are withdrawing. Suppose if it is yesterday was a weekday and the day before yesterday was a holiday, people are withdrawing less amount of money. Okay, and there are other transactions. So what is happening here is, without actually writing any code, without actually, you can see lot of trends. Okay, which month, January how many, February. So I have not told anything. All I did was just uploaded the data, and quarter by quarter, which quarter it is doing well, which quarter it is doing bad. All of these data comes automatically. I don't do anything. Okay. On weekdays, more amount was withdrawn compared to holidays. So, as a end user, or as a manager, or as a person, again, these filters can also I can do. I want to see only big street ATM. This comes automatically. I didn't do anything, right? All I did was just it just gave the data and say you draw the graph. It automatically draws the graph. This is also called as auto EDA, or automatic exploratory data analysis. It is not just exploratory data analysis, it is beyond that. Okay, so I have the data and it is giving me charts. No, you can come and say, I don't like this charts. I want to make my own chart. Like I want to see what is the trend of amount being withdrawn on all the months. Okay, so that is also possible. You don't have to write any query. All you have to say is just ask a question, okay, a custom question. and select the database, select the table. What do you want? I want to get the average of total amount withdrawn grouped by transaction date, month. Okay, I can say visualize. Automatically chart comes. Now you want to convert that into a bar chart, you can convert that into a bar chart, right? If you want to see, so this is for all the months. Suppose if you want to further, you know, transaction month of the year. So you want to just to see in January how is it, in February how is it. So each month. So now you can see that you are able to create a chart, or you have only thing is that you need to give the data. The moment you give the data, you are able to again. So from here also, suppose now, okay, I see that in this month there is lot of transaction. In this month, which ATM is giving more money? Just click on it. You will get the drop. Sorry, there is an error. I don't know what I did. Because we keep on developing it, there could be cases when it can break. Okay, let me just do it based on the weekday. Okay, I don't know it can even break. Okay, maybe I can slightly do it in a different way. Filter by weekday as Friday. Usually it automatically filters, but in this case it didn't filter. So the point I'm trying to show you is that data analytics means not as a, okay, there are two areas to it. One, as a developer, what you can create, okay, by yourself as a data scientist for your own purpose. But that is not the end goal. The end goal is to create a system where people can understand the data by themselves without the need for others. So in this case, if I want to create, if I want to do a, a simple visualization, I can simply say custom question, bank, ATM. I can say amount withdrawn. Okay. I want to see two things. I want to see things how the amount was withdrawn from the CUB ATM and other ATM. Okay. So average sum of, sorry, yeah, sum of amount withdrawn using CUB card, sum of amount withdrawn using other card. Okay. And group by transaction date, by month, or say day itself I will say. Okay, and say visualize. So for the last 5 years, how the amount, so you can see that, right? So it slowly, see, nobody wrote a query here, right? Nobody wrote anything. You just selected what you want. Can somebody tell me what happened here? It went so low. Can you take a guess what happened there? No transactions happened during that time. It is, if you look at it, it is somewhere between November to 16th, that time. Can somebody guess what happened? It was the demonetization time where ATMs never had any money. So I'm having 7 years of data which is shown in a single graph, and you are able to make sense out of it. And one more thing, if you understand, if you observe it, the amount withdrawn from other cards increased after demonetization. Before this, the green was above and blue was below. After demonetization, it flipped. I don't know the reason. Okay, but what we are trying to say here is, we are saying that whenever we are creating the data analytics for the BFSI sector, one of the important aspects here is that, one, we need to have stunning visualization. From the visualizations, people should be able to make sense out of it. Point two, we need to have on-demand metrics. Whatever you ask for, the data from the data, whatever you ask for, I should be able to create a visualization out of it. It could be, you might want to say on which day. Let's say it's a simple question that I want to ask. Okay, on what day of the week, right? More amount of money is getting withdrawn. Say average of total amount withdrawn to by day of the week. I think summarize. So you can see quickly. You have the data. You can ask whatever you want, and it is readily available. Right? So now there are a lot of such tools. Okay, we are not telling that this is the only tool available. There are a lot of such tools, but what we did in Data Libre is that we created a platform in such a way that data can come from multiple sources. They can be combined into a common data model available to the end user. All the things that the end user has to do is he has to just log in and ask whatever questions he has. And once he is done with his questions, he can very well save them. He can save the questions, add it to a dashboard. I can create my own dashboard. Right? This is a dashboard. I can place it wherever I want. All these things I can do. Once it is there in the dashboard, I can again go ahead and drill down. The drill down is not working for some unexpected reason, which we will fix it. But so all these kind of things are doable. All these are required from a data analytics person. Data analytics is not always creating charts and visualization on a Jupyter or notebook Python. That is from a very academic perspective. That is needed. I'm not telling that's not. That is the base. But at the end of the day, what is required is we will need a system where anybody who can operate a browser should be able to do data analytics. That is our end goal. Okay. Coming back to our. Okay, so this is what about the data analytics. So this is one of the major activity for any of the BFSA sector. Okay, they might want to understand the market patterns using data analytics. They might want to understand the credit risk. Credit risk means who will be able to repay the money, who will not be able to repay the money, which company can go default. All these kind of things people need to know. Customer engagement. How do I engage my customers? How do I keep my customer happy all the time? All these kinds of insights can be, given that you have data, you can bring different kinds of insights using your data analytics tool. Now, when you are creating such a data analytics tool, the important aspects here are, one, we need to have a clean UI, a clutter-free UI where people can do their analytics on their own. Once they do it, they should be able to share it with somebody else. It's not that I should be able to keep it for myself, right? Second, all these dashboards or charts that you do should have the ability to drill down and filter. When I say filter, I just showed you, right? I can filter it based on a ATM name, or I can filter it based on a weekday. A lot of filters that is possible. Why we need is, we don't know what cross what will actually give us the answers. There are so many permutations and combinations that are possible with the data. And what we are trying to do is, we are trying to create a platform where people can do whatever analytics they want.
Hello. Hello, sir. Sir,
Yeah, go
hello,
ahead, go ahead.
sir. Sir, there are some disturbances, sir, in the
I'm
background
just
noise.
checking it. Wait, wait. 1 minute. Is this fine now? Is this fine now? The background fine? Now
Sir,
it is
now
fine,
it's
right? Okay. I think the neighbors were
yeah.
had their cooker on, so I can't stop it. But now I think their cooker switched off. Okay. Okay.
Okay.
Anyways, so the idea is create a data analytics platform where people can do their own analytics using self service dashboards and stuff like that. So data libre is one of the answers for that. There are multiple such answers available in the industry. But why data libre is because this is open source. Anybody can start using it and maybe start a company out of it and start creating data analytic solutions for a bank. Okay, that is the whole purpose of that. So that is one area where we started using the data libre platform. Second, the other things that we usually do in our day-to-day lives is the time series forecasting. Time series forecasting is mainly the univariate timestamp. In certain times, we might not get. So, for example, the branch might give daily collection of loans. They just give only one column. Maybe date will be there, but the actual this day, this amount, no other information. This is a univariate data. Okay, maybe the number of loan collections, or it could be number of branch visits. Like this, so many such, univariate data will come. When I said univariate, I just have data for one column. In such cases, we use time series forecasting. Time series forecasting is basically we use concepts like exponential smoothing, halt winters, ARIMA, and Prophet. One of my favorite tool is Prophet. Prophet is an open source time series forecasting engine by Facebook. Okay? Facebook has developed a open source time series forecasting a tool or an engine which is called Prophet. Many of you might know what is exponential smoothing, what is halt winters, ARIMA, and Prophet. But if you don't know, you can go ahead and look at them, what they mean, and how do you do that. A lot of Jupyter notebooks available. But what is that we are trying to do here is we constantly keep collecting data over the years, and one of the important challenges that we face in time series forecasting, there are so many academic industry people, researchers available here. This could be a very interesting challenge. When we are trying to do forecasting, one of the important things in forecasting is seasonality. Suppose, for example, in banks, okay, in banks or in retail, Indian industry, the buying and selling is closely connected with festivals. Okay, so basically, what happens is people buy a lot of things during Diwali, or they buy a lot of things during Pongal, or there's a lot of economic activity going on during Ganesh Chaturthi or during Ramzan, okay, and during Christmas. Each of these festivals, there is a lot of economic activity going on. So whenever I'm using this time series forecasting, we are unable to properly predict it because Diwali will not come on the same date next year. It is basically based on the Indian calendar. All these, these time series forecasting techniques are all based on 365-day calendar. Christmas, no problem. It always comes on December 25th. I don't have a problem, right? But for all the other Indian festivals, there is a big problem, because this is not dependent on the calendar date, whereas all our engines and the coding and all the other stuff are based on the Julian calendar. Unfortunately, there is a big gap here. Time series, for every time we will have to adjust it. We will have to do it manually. Okay, this is a big problem. So all the people who are trying to do some research on time series forecasting and stuff like that, this is an interesting problem which many of the retail and banking industry do face with respect to predicting this based on the time. So we adjust the dates, we adjust the time frames. Okay, so but yeah, we somehow manage it using different variations. We adjust the calendars, we adjust the frequency of the calendar. So this has to be done every time, every year, maybe time and again. Okay, so this is okay. There are different ways, but try to see if we can have a package which basically correlates to the Indian calendar rather than a Julian calendar. I don't know if it is possible, but yeah, it's an interesting problem to solve. Then comes um, the regression use cases. There are many regression use cases that we do. We predict the amount withdrawn from an ATM. Why should we predict it? Because if I load more money into the ATM, I don't want my ATM to go dry. Every time my customer comes to my ATM, he should have the money. Okay, he should not go back empty hand. Maybe if there is no money in his account, I can't help. I can't give him money for that. But if he has money in his account, he should be able to withdraw. I don't want my ATM to go dry. One way I can do is I can put lot of money in it, but that's a problem. The problem is money outside the bank is called liability, and the bank has to pay insurance for that money that is lying in the ATM kiosk. So no bank will load unlimited money in the ATM because they have to pay insurance for the amount that they load. So they will load only exactly the required amount. But when you load the exact required amount, it might go dry. So we want to create a prediction engine which will predict exactly how much money will be withdrawn. Okay. So for that we collected a lot of data. Okay. Okay. So we collect a lot of information about the data. This is not a lot, but a good amount of data that we collected regarding the ATM machine. CSV file. Again, this is a anonymized data, so it is okay for me to show it. It is not a non-disclosable data. It is a disclosable data. Okay, see, these many parameters we collected. Number of shops around the ATM zone, rural, right? There are a lot of zones like that. Number of other ATMs in 1 kilometer radius, right? See, it might be very simple to actually do a machine learning model after the data is given, but collecting the right amount of data for prediction is much bigger task. Okay, now see what all data we collected. Number of other ATMs in 1 kilometer radius, number of houses, ATM placement, is it facing road or is it inside, ATM type, ATM location type, only withdraw, deposit, that type is there. How the ATM looks, whether it is a fancy new one, normal, old one, is it near a college, temple, shopping complex, park, right? Number of withdrawals attached to a building, petrol bunk, some are attached to shops, right? Average number of withdrawals per week, waiting time, day type, right? ATM rating, ATM proximity, right? Whether it is attached to a bank or whether there is an ATM next to it, right? When is the ATM sense? Like that, we collected a lot of information to basically withdraw. See, to just predict this, see the amount of the data that we have collected. So we keep on collecting so much amount of data to do this predictions. Okay, so that was an example of that. Okay, so similarly, we predict NAV values of a fund. Net asset value is what we call lifetime value of a customer. So basically, there could be a lot of customers. how much business I can do from this customer. If I can do more business, I will give him more offers. I will treat him royally. He comes to the branch, I'll give him coffee. Right? I need to treat him well. If he is a highly valued customer, I need to treat him well. Not that the person who is not valued, you should treat badly, but this guy will get a better thing. And another example is home loan yield prediction. That is, bank has given you a home loan. How much money they will make out of it, which is called the yield. Okay, peak time load. When there is going to be peak load on the net banking and mobile banking, credit score, like that, there are a lot of use cases. Now the problem is the bank has the data. Just understand this. The bank has the data. Machine learning, I can use machine learning to do it, but who will do it? You might have to involve one data scientist to do it. But this is a common machine learning problem. Given the data, I should be able to predict it. Okay, so that is where we brought in something called as self-service machine learning tool. Means you load the data and do the prediction by yourself. You don't need a an expert for that. Okay, so you can see that here we created something called as an ML Studio. You can use the URL. This is just a beta version of it. The pro version is available, but is available only to some of our subscribers, not customers. We don't sell anything. So some of our subscribers, we do that. So here I'm going to show you an example of how this tool can be used to do both classification and regression without actually writing a piece of code. You can always argue.
Sir, I'm not hearing anything. Is it muted?
Yes, sir. Audio is not there, sir.
Kaushik,
Hello, sir.
Kaushik, sir. Kaushik, sir, you are not audible.
I think he pressed a key on the laptop, sir.
Hello.
Some function keys are there. I think so.
I'm sorry, just a minute.
Okay, sir.
Kaushik sir. Okay, he's not audible.
Santosh.
Oxaline on. Sir?
Oh, if you're busy, we can talk later.
No, sir. Like I'm talking to Kaushik sir only. He has some issue with his mic.
Oh, that's right. Okay, but fine. Resolve.
Okay, sir.
Hello, can you guys hear me?
Yes, there is.
1 minute. Okay, I'm connected via phone for the audio, and I will try to share the screen. Let's see if this works out. Okay.
Okay, sir.
Okay, I'm just presenting. Let me know if your screen is visible. So is the screen visible now?
Not yet, sir.
Now?
Yeah, yes, sir.
Okay. So what I will do is I will be talking via phone. I will be talking via phone and presenting my screen. In case if you have any issues, please do ping me immediately. I think I was talking about from when was the audio lost?
Sir, from the 6th slide, sir.
From the 6th slide itself.
Yes.
Oh, from the so you never heard of the time series that I spoke and these things?
No, sir.
Oh my God! Somebody should have told me that. Anyways, okay. Let me. Okay, so at least from the inferential statistics, was that audible or was that also was not audible?
Yes, sir. Start at the 6th slide. There is no audio, sir. When you start presenting the 6th slide, the audio went off, sir.
Oh my God. Okay. I think for the sake of time, I will try to quickly run through them because I mean, from that to this, it is okay. Anyways, okay. So, in the banking industry, we do a lot of inferential statistics. So in the inferential statistics, what we try to do is there is lot of data that is okay. Santosh, I may take 5 minutes extra to complete this, maybe around 120. Okay.
Kaushik, no issues, Kaushik.
Okay. I think because of the size of the call, my audio automatically got muted.
Oh.
So
no issues, sir. You can
okay.
we'll adjust it. No issues.
Okay. So anyways, okay. So in the banking industry, we do a lot of inferential statistics, especially when you say inferential statistics, this is mostly with respect to the hypothesis testing. Now, what kind of hypothesis that we have? For example, somebody can come and say that the performance of the branch at Hyderabad is different from the performance of branch at Chennai. So one way is you can quickly take the average and see, but that's not always going to work. You might have to statistically prove that there is a significant difference in their performance. In such cases, we would be using the concept of inferential statistics. Example, if you take one of the applications, people, those who fill their loan application form with proper capitalization are less likely to be default. So there was a huge research done that on the using big data. What they did was they found out how people are filling their loan application form. People who fill their loan application form with proper capitalization, proper punctuations, they are less likely to default. It is very obvious that these people are more, rule followers. They follow the rules. They won't, default, right? So next time when you go to a bank for a loan, fill your loan application form in with proper capitalization and punctuations. You are more likely to get a loan. Okay, it's one of the so. How do we come to these conclusions, right? We have data. The banks have a huge amount of data, but how do we come to the conclusion? We come to this conclusion only based on several statistical hypothesis testing that we do. Okay, for example, there is a case. Our NPA is as per the market standard. Our NPA means one bank. Market standard means the entire banking industry. If you understand your hypothesis testing class, or the things that you have learned, you would have heard of something called as sample, and you would have heard of something called as population. The entire banking industry is the population, and that particular bank is the sample. Now you have the samples NPA and the market's NPA. Now you want to prove that your NPA is same as that of market NPA. What statistic testing technique you will use? Can somebody let me know? You know your bank's NPA, which is your sample. You have your market's NPA percentage, which is the market standard. And now you have all these data. What kind of test you will do to prove that your NPA is as per the market standard? Am I at least audible?
Yes, sir, you are audible.
Okay. So I
Yes,
thought.
sir, audible.
Yes, sir.
Okay. So what kind of test you would use? So I know some of you might know the answer, but are not reluctant, or maybe reluctant to answer. One of the Z tests you would use, depending upon whether you know the population standard deviation or not, or whether you have only sample standard deviation. Based on that, you would use one of the Z tests to prove that. Similarly, the city X and city Y are having same proportions of news depositors every year. Again, another variety of Z test. Z test on multiple proportions. So maybe when you are studying that in your things, you might not be able to clearly articulate how this would be used. So some of the common examples of how this is used in the industry is to drive or to derive conclusions from the market, to derive conclusions from within the branches. We would be using these inferential statistics. Okay, so these are some of the. So one of the other use cases is the ATM next to the branch is not reducing the burden on the cashier. Suppose if I put one more ATM machine next to the bank branch, am I reducing the workload on the cashier? Or am I able to reduce one cashier and put him into a more productive work? Okay, so that is another test that I can do. So there are a lot of such inferential statistics being used in the BFSI sector for deriving conclusions on how we are doing the business and how the business is running. Then comes the data analytics part. So I think this is where my voice was not visible. My voice was not audible. So in the data analytics, sector. So in the data analytics sector, what we wanted to do was, we wanted to create stunning visualization. That is visualization where people can do their analytics on their own. They should not be able to, they don't have to rely on a SQL person. I have the data. I should be able to do the data analytics on my own without writing SQL query, without writing a piece of code. That is the major objective of the data analytics. That is where our actual data libre comes into picture. I think I showed you this, but there was no voice. Okay, now I'm going to show it to you again. So here, this is our data libre, one of the visualization engine that we use. Now in this, if you look at this, we have our bank ATM database. Okay, the ATM data is available there. So I go to this ATM data. Now I have a lot of data like the branch name, the transaction date, the number of withdrawals, the number of card withdrawals. A lot of things are there. Okay. Now from this, I want to draw some data analytics. I want to create some charts. I want to create some visualizations which will help me explain the data in a more digestible way. I should be able to understand it clearly. Now, if I want to create such a visualization, I need one expert, a database expert who can write the query, and I need one front-end developer who can create the charts. Okay. Now, this might not be always possible because I think somebody has to put their mind.
Kaushik sir,
Okay. Yes.
I'm sorry to disturb. Like your video was like on in both.
Now is it off?
Yeah, it is off. Yeah.
Okay, sorry, thanks. So, here what we are, okay, somebody, can you mute yourself? I'm hearing my own.
Yes, sir. Audio we are getting from both devices.
So suddenly this started working, I think. Okay, I think my Chrome also started working. Okay, so let me try this. Can you hear me now?
Yes, sir. It is clear.
Okay, now I am coming from my own laptop. I think the laptop suddenly, maybe somebody left and it started working, I guess. Anyways, in case if it is not audible, Santosh, please call me immediately.
Sure,
okay.
sir.
Okay, so coming back to this thing. So I have lot of this data. Now what I wanted to do is I want to create a visualization out of this data without writing any SQL query, without writing code, without writing anything. So what I can do is there are two ways in which we have developed the system. One is it will automatically create the dashboard without anything. Say for example, I come to this data and then I say X-ray this table. So what it will do is it will create the visualization on its own. This is not done by me. Remember, I am not doing anything here. I am just saying create a dashboard for me. It is automatic. Whatever be the data, it need not be financial data. It could be any data. Okay, it could be any data, and it will automatically create the possible dashboards. Need not be exact dashboards that you require, but it will kind of create the possible or the most suitable dashboards on its own. Here, the person who is using it need not write the code, need not create the visualization, nothing. The date, all you have to do is just provide the data and then it will automatically create it. This is called auto EDA, auto exploratory data analysis, where you give the data, it automatically creates it. It can also filter on its own. This filter was not created by me. No festival. N means no festival. So it automatically creates the data. I did not create this data. It will automatically create this dashboard. So all of this are happening automatically. This is one of the features of our Data Libre platform. Is my voice clear till this point?
Yes, sir.
Okay. Now, okay, one part is it is automatically creating it. But now I might want to create my own dashboard. I want to ask questions to the data and find answers. I don't want to write query now also. You just go and say ask question. Okay, and you select your database, and then now I want to know how much money was withdrawn month-wise, right? So I simply say sum of total amount withdrawn, pick by column transaction. This is automatically coming. We are just providing the data. The tool automatically gets all the required filters and stuff like that. So I say now month, and then I say visualize. So no code required, nothing. It will automatically start creating the charts. Can anyone tell me what happened here? Can tell me, somebody say why it was a sudden dip here?
Sir, demonetization.
Exactly. So I have shown you 7 years of data, and within a minute you are able to tell what happened. That is called stunning visualization. People should be able to understand the data with, see, forget about technology. Technology is one portion of it. The idea about having a proper visualization or a proper data analytics system is to derive the stories from the data without much of the effort. Behind the scene, anything can happen. But from an end user perspective, this is what we are expecting. Okay. Create visualizations or create systems where people can do by themselves. You should not be expecting an SQL developer for that. This is how we are evolving as a data analytics ecosystem in the market, especially for the BFSI sector. Okay. Now in this, there are a lot of options. Suppose I want to know on which day of the week more amount of money is getting withdrawn. I can simply say bank, ATM, then I can say sum of or average of total amount withdrawn, group by transaction date, day of the week. I say it, visualize. So you can see on Saturday more money is getting withdrawn. People are going to a lot of parties on Saturdays, so they are withdrawing a lot of money from it. Whatever be the reason, maybe they are going to for movies, whatever. So see, we are able to digest that 7 years of data without writing the code. That is what is expected in the industry from a data analytics perspective. Okay. Now you can now save this data, create dashboards, right? Save, add it to a dashboard. I am adding. So I have already added one. I can add one more. I can add any number of such dashboards. See, this dashboard is again created without writing a code. And I can share this. I create this, I can share this, right? So how seamlessly the end user is able to extract information from that data. That is the key for data analytics. And this can be derived or this can be done only by creating self-service data analytics platforms. You cannot always ask your a person to write a code in Jupyter notebook and create analytics. Yes, that is also important. But in a business, from a non-technical perspective, these kind of things are very, very important. Okay, moving forward. So next is the time series forecasting. I will quickly do it. Most of you might know it. Here in this case, what we are trying to do is we have lot of past data. Based on that, we are trying to predict the future. We are trying to predict how the future sales will be. Okay. In this, we use exponential smoothing, Holt Winters, Arima, and my favorite is Prophet. Prophet is a open source data analytics, time series forecasting engine by Facebook. Facebook has created a completely open source time series forecasting thing, and this can be used. One of the important challenges that I want to bring up in the time series forecasting is time forecasting for Indian calendar. Most of the times what happens is our entire economy is based on festivals, right? but the calendar with which all these languages are built are based on Julian calendar. Now the problem is I can predict for Christmas because it always comes on December 25th. But Diwali always won't come on November 17th. Sometimes it comes in October, sometimes it comes in November. So matching to the Indian calendar for the time series forecasting is an important problem that many of us have not researched it. So people who are trying field of researching and time series forecasting, especially in the financial areas, can think of this as an interesting problem to solve. Okay. Matching the forecast for the Indian festivals is an important problem that people can try and solve. Then comes the regression problems, where we try to predict the amount of money withdrawn from an ATM. Suppose if there is an ATM machine, how much money can be withdrawn from an ATM? Why is this important? Because I don't want my ATM to be dry. I want my customer to get the money whenever he wants. Okay. For that, I cannot load more money. If I load more money, I need to pay more insurance. Any money taken out of the bank is a liability to the bank, and the bank has to pay insurance. So I cannot even pay more insurance. So I need to exactly size my ATM, cash thing so that it won't go dry nor it gets wasted. So I need to create that. Okay. Then these are all the other cases. So for example, when we wanted to predict for the ATM withdrawal, we collected a lot of data which influences the ATM withdrawal. I think I have shown it to you. I'm just, maybe you would have just seen it as the screen, but I'm just opening it up now. Okay, so you can see how many fields we have collected for this. So we can see number of shops around that ATM, ATM zone, number of other ATMs, estimated number of houses, ATM placement, ATM type, ATM location type, looks of the ATM, whether the ATM is near the college, temple, shopping complex, park, school, railway station, residential, office area, tourist place. Lot of such information has been collected. Okay, number of like this we collect. So one of the, okay, given the data, many of us can do prediction, but collecting the right amount of data for prediction is an art by itself. Comes with lot of experience, no technology required. Okay, but it see this now I can confidently say that for this particular bank I will be able to properly predict the ATM because this is the amount of research that has gone through. There are a lot of such things that are collected. Similarly, I will be sharing these data sets also at the end of the session, where you can understand how we collect data sets for different solutions. Now, one problem is collecting the data set. The other problem is doing the actual regression or prediction. Now, here the problem is I need to find an ML expert to do that. Instead of that, what we have come out is we have come out with a self-service machine learning studio where people can do machine learning without writing code, upload the data and predict. Okay, so here what we are trying to do is we say browse. A simple example I'm taking. Okay, this is a online version, a beta version which cannot take big files. I can share you the code if you want to try it out. I'm just going with a small slide. So I want to do a regression on the Boston housing data set. I submit the data. I'll immediately get the data. Now, in case if most of the times it will guess the format correctly. In case if it is not guessing correctly, you can change it. But in my case, it has properly guessed it properly. Then I can also do some small visualization to check if it is normally distributed and all the other stuff. So for example, I might want to do a box plot on the, right? So I can choose the, right? So I can see if it is normally distributed. Maybe I can also see age based on something, let's say Pareto, something like that. So again, this is still again a drag and drop kind of visualization, where you can try to explore the data for yourself. Once you have done with the exploration, you can actually go ahead and start building the model. You can go to the build. Okay, what do you want to predict? I want to predict the median value. Using what you want to predict, you can specify all of them. Okay, then you can specify your test to train split, number of models that you want to generate. Okay, it uses different algorithms. Okay, then some seed value. If you want to do a cross-fold validation, how many cross-fold validations you want to do. Okay, and then you can say run AutoML. What it does is it will automatically create a model and display 4 models. I have now set as 4 models, 4 best models that I can use for prediction. Okay, so so what are we trying to do? We are trying to eliminate the need for an actual data scientist here. You cannot eliminate him completely, but what we are trying to do is we are creating a system wherein it is easy for the end users to try out prediction. Okay, it might have to be tuned properly, hyperparameter, a lot of things, but that comes later. To begin with, he can start with basic predictions. Okay, without actually writing any piece of code. Okay, wait, it will take up to a minute. I'll do one thing. I'll just go with one model so that I can easily show it to you now. Just for okay. So now it says DRF is distributed random forest. So it says that this model is the best model. Now the model is created. Now I want to predict it. So I can say predict. Now it is asking me the test data, the new data for which I want to predict. In this case, I'm using the same one. And I say submit. And I say predict the values. So it uses the predicted this thing. It will download. You can also download the. See, now you can see the predicted value. So it has the actual value and predicted value. So what we have done, we have created a system, or what is required. We require systems where I don't have to write code, I don't have to write SQL. All I do is I give my data. It will take care of normalization. All these things behind the scenes happen behind the scenes only. The end user need not know about all these things. Okay, he'll just go ahead and do that. Same thing applies to classification also. If I want to do classification, I can upload a classification data and then I can do a classification. So what are we trying to do? There is one portion which is core machine learning, where you develop models, tune them and all these things. But what is required in the industry is basically applications with which anybody should be able to do data analytics. Anybody should be able to do machine learning. Okay, now again, classification, how classification is used. If I want to use loan defaulters, logistic regression, fraudulent transactions, naive base, customer churn prediction, CART, classification and regression trees, how much money I will make it in the stock market. You want to do a stock market prediction, use K. So a lot of things are used for different purposes. These are from my experiences, where and all I have used. Okay. Again, clustering, we do a lot of clustering, basically to segment the customers, to find which are all the customers who are all together, right? So that I can offer them proper, customized solutions to them, right? Targeted this thing, I can do that, right? And then we also use deep learning. So deep learning is basically we use for, sorry, this is not drone. Drone-based crop inspection. So we have created a system where a drone will fly across a tea estate and find out whether I can give the loan to it. Basically, we inspect that. So a bank, a person need not go there. Can just stand outside, run the drone, collect the images. The machine learning algorithm will tell whether loan can be given or not. Second, cattle identification. What happens is many of the banks give loans based on the cattle. Suppose I have a cow, I can take my cow and take a loan. But what happens is my friend can also take the same cow and get the loan. So what I can do, I can create an artificial intelligence system which will detect the cow, like how we are detecting the faces. Cows can also be detected. Right? There are a lot of documents available in the banking. It can be scanned and processed using MPL. Face analysis system for monitoring customer interest. Suppose I'm trying to sell a product to my customer. I will analyze his facial expression to see if he's interested or not. Then some chatbots and robotic things. One of the recent things that we did during the COVID was to create a system to allow only people who wear masks. I will show you that. So this, which will detect people who are wearing masks and people who are not wearing masks. This is me. So I'm just running it. You can see that. So I'm just bringing up a system where the door of the ATM will open only if you wear a mask. Otherwise, it will not open. Okay. So we created a system which will do that. You can see that. See, now I don't wear a mask. Right now, you're seeing that I'm not wearing a mask. The moment I wear the mask, it says, right? So see, there are a lot of applications of these kind of things in every industry. Only thing is that how we are utilizing them for these kind of purposes is an important aspect. So going forward, what are we trying to do? We are trying to do explainable AI, which will tell why something has happened. Okay, an auto ML. I showed you an thing, right? You give the data, it should automatically do the machine learning and give. I should not be writing the code for which somebody has already written it. And ethical and smart data. Ethical AI means AI system should behave in an ethical way. Okay, you can read more about it, ethics in AI and all this stuff, and smart data. Okay? And then comes the Data Libre part, which is an open source initiative. You can all go to this site called datalibre.org.in. Our big Bitbucket URL is there. You can download the sources for our products and our materials and frameworks and all these stuff. You can also have collaboration with us through IIT Madras, and maybe in terms of internships, in terms of projects, whatever is possible. And thank you. This is about me. You have any questions, you are welcome. Sorry for the no voice in between. Hope I was informed.
No issues, no issues, no issues. Selvan.
Okay. Anybody has questions?
Thank you, Kaushik.
Please go ahead.
Mercy, you can take down their email IDs and keep it, huh? Prakash. Okay, I think so. You should have we are taking, sir. Very good, right? Okay, Santosh. Okay, Kaushik's email ID is
COE 19T005, sir.
He is a Resilio employee here. Okay, COE.
I will put I will write it. Kaushik R. Resilio-labs.com. Yes, you can take my email ID.
Thank you, Kaushik.
No
so
problem.
Keep in touch, right? He's an excellent person for application of data analytics for healthcare, right? All those. And I think by now you should be Mercy, me, and Santosh, right? If you ping as well, we will redirect to the other speakers around. We will surely consolidate the contacts and share you shortly. Santosh, you can close the recording.